Hello, in this video we're going to look through a few questions on partial differentiation and how we use partial differentiation when we want to analyse a utility function and a production function. We'll just look at the first question here. We have if z equals 2x over y plus 9x squared by y up to the power of 4, then find these partial derivatives del z del x and then del z del y. Okay, so before I even begin to think about differentiating that z, I don't like when there is a letter or a variable on the bottom of a fraction because I can't handle it straight away. What I mean is, I don't mind x up to the p, okay, when I've x up to some power p, because if I need to differentiate it, all I do is take the power down and subtract 1 from the power. But when I have 1 over x to a power, then I have a little bit of a problem because I can't use this rule straight away. So what I need to do, I need to take that x up above the line, nearly above the line. But when I do that, I must change the sign of the power. Now I'm ready to differentiate, because all I do now is I take that power down, so the power is minus p now, take the minus p down and then subtract 1 from it, and I'm happy enough with that there. So in that z, any letter or variable that's on the bottom, I really need to take it up above the line. So the only letter on the bottom of a fraction there is y, so I'm going to take him up. So what do I have? I have z equals 2x, nothing happens to 2x, but I'm taking the y up. So what the power on the bottom, even though it's not written, it's 1. So when I take it up, I need to change that to minus 1, okay? On the next term, there are no variables on the bottom of a fraction, so I can leave it as it is. So I'm fine with that, okay. So the first partial derivative I'm asked to find is del z del x. Okay. Now, that means differentiate z with respect to x only. So if there's any y anywhere, you ignore it. Treat it as if it's a constant. Now, what I'm going to do here is to make life easier for myself, I'm going to rewrite z. And I'm going to put, for every term, I'm going to put a box there, sort of a bin. And in this, I want del z del x. So if in every term, if it is not x, then I don't need to know about it. It can go in the bin almost. So what I'm going to do, in that first term, 2x y to the minus 1, what I have 2, I'm going to put 2y to the minus 1 in here, because I don't need to know about them. And the important term here is the x. I'm going to do the same for the next term. I'm going to draw a box here and put anything that is not x inside the box. So I have 9y to the power of 4. Okay. Why exactly am I doing that? Because I'm doing that because now I'm going to treat that as if that may as well say 5x plus 7x squared. Okay, because whatever's in that box, treat it as if it's a constant. Okay, so now if I need to differentiate that the z with respect to x. So I have del z del x equals, so if it was 5x, you would just say the derivative is 5. So it's the same idea with that box. Read that as box x plus box, I'll go up the screen a little, box x squared. You would say, sure, the same with the 5, the box is just left over on its own. So you'd say the only thing that stays there is the box, and just put whatever was in it back into the box, okay? And in that term, the same idea with, if you were differentiating 7x squared, you would say, take the 2 down and take 1 off the 2. We're going to treat this above as the same as well. We have box x squared. You would say, sure, just take the 2 down and take 1 off that 2 there, so I'd just be left with 1, and put whatever was in the box back inside it. Okay, so now I'll just clean up the whatever I have, all them terms. So I have 2y to the minus 1, nothing to be done there, plus 2 by 9 is 18, and I'll have 18 y to the power of 4x. Okay. And don't be afraid now, I took that y above the line because I needed to differentiate, but don't be afraid to throw it back down now to the back under the fraction again. So I'll be left with that 2 over y plus, and nothing to be done here, 18y to the power of 4x. Okay. Now, the next thing I'm looking for is del z, del y. Okay, so I'm just going to take my z down again. I don't have enough space to look back at it, so I'm just going to take it down here. I had that again, that was my z. Okay, so now this time I need to differentiate with respect to y. So I'm going to use the same thing about the bins or the boxes. Throw everything that is not y this time into a bin or a box. So let's draw the little box we have. So what we're left with, there's a 2 and an x, so no y there, nothing to do with y. So on the outside, the major term is the y. And the same idea here, there's a 9x squared, I can bin that, I can ignore it, and I'm left with y to the 4 as the major term. So again, just pretend, even draw it for yourself, just make up any fake equation. Treat that to you, that may as well just say 7y to the minus 1 plus, any number at all, 11y to the 4, okay? And say, how would I differentiate that? Well, what you would do is take the minus 1 down and take 1 off the power. And again, when you get over here, take the 4 down, the 11 is there to meet it, and take another 1 off the power. So treat the equation with the box as exactly the same. So that means we have del z, del y equals, so I take the minus 1 down in front of the box and take 1 off the power, y to the minus 2. Fill in whatever was in the box, 2x. Plus, again the same idea, take the 4 down in front of the box and take 1 off the power. And what was in the box again? 9x squared. Now, you can clean up everything now. What will we have? We'll have minus 1 by 2 is just minus 2x, y to the minus 2. Okay, plus 4 by 9 is 36. If you're stuck on that, just quickly go over the calculator. 4 by 9, 36. So x squared, y cubed. And again, don't be afraid that just because I took the y above away from the bottom of the fraction, put it back down to the bottom again. So we have 2x on the top and y squared on the bottom. Plus, and nothing more to do here, 36x squared, y cubed. And that's the two partial derivatives. Okay, let's look at the next question. Now this question is a little more tricky looking. But I'll use the exact same approach as before. As I said, before you even think about differentiating anything, when you see a letter on the bottom or a variable on the bottom, you need to take it up above the line. Now, I shouldn't have a big problem taking up that y cubed, because when I take that above the line, I'm going to get y up to the minus 3. But what about that square root of y on the bottom? Okay, let's just go to the side of the page for a minute. Now, if we have the square root of something, okay, the square root of s, the square root of something, then that is the same thing, and I'm afraid you'll have to remember it. That's the same thing as s up to the half. Okay. Now, but what about 1 over the square root of something? Let's take it in steps. Well, the first thing I'm going to write it as 1 over, I'll use the rule I just wrote a second ago, 1 over s up to the half. But then from the last question, if I want to take a variable up, I can take it up, but I must remember to change the sign of its power. So I'm going to get s up to the minus a half. Now, so let's just rewrite that z and take all the letters up to the top. Okay, so I'll have z equals minus 7x squared. That's no problem there. But that over the square root of y, that changes to y up to the minus a half, as we said at the side of the page. Okay, now be careful. You're not doing anything. You're only making z look better. You're kind of preparing it for differentiation. You're getting it ready so that you can differentiate it. You have not differentiated it yet, so don't be writing z dash equals that. It's z dash. We didn't even find that yet, or del z del x. We're only rewriting z, getting it ready so we can differentiate it. Now the next term, I'll have 3 over 11. Now that's square root of x. I'm just going to keep that's x is on the top, so I don't need to change the sign of any power. It's on the top, but I'm going to rewrite the square root of x as x up to the half. And then the y cubed in the bottom becomes y up to the minus 3 on the top. Okay, what am I looking for first? Del z, del x. Okay, so like before, throw everything that is not x into the box. Okay, so I'll have x, the major term is x squared there, plus, and the next term, the major term is x up to half. That's all I care about. Everything else can just be thrown into the box. So in the first box I'll have just minus 7 y to the minus a half. And on the second box, 3 over 11, don't need him, and y to the minus 3, don't need him either. Okay, so now we're ready to find del z del x. We'll have del z del x equals, and again just write a sort of a fake equation. Just put in numbers instead of the boxes. So maybe put in 5x squared plus 2x to the half, and say what'll happen. How would I differentiate that grey equation? Well, it's the same as you always do. Take the 2 down, multiply it by the 5, and take 1 off that 2. And when I get over here, take the half down, multiply it by the 2, and take 1 off that half. And it's the same idea with the boxes. I'll have take the 2 down in front of the box. We'll fill the box in a minute, and that'll be x up to the power of 1. And over here I'll have take the half down in front of the box, and I'll have x up to the, now if you're stuck on fractions, don't be afraid to just throw it quickly in the calculator. If you're not 100%, if you're not confident adding and subtracting fractions, this calculator is brilliant because he can do it all for you. So I know it's a half minus 1. And what do I get? Minus a half. And the calculator gives you the answer back in fraction format. So I have minus a half up as a power there. Okay. Now, so throw everything that was in the box back in. They don't change. They were just temporary terms. They don't change at all. 3 over 11 y to the minus 3. Now, let's clean up. Now, we'll take it slowly. So, all you can do is multiply like with like. It's numbers by numbers and letters with the letters, and the same letters each time. So, we'll have minus 14, okay, y to the minus a half by x. That's fine. And then I'll have a half by 3 over 11. Now again, if I'm not 100% sure, how do you do that there? Just let the calculator do it. So I have a half, and I can literally write them beside each other. 3 over 11. Oh, whoops, maybe that wasn't a great idea. Let's clear that again. So maybe we'll just do a half by 3 over 11. And the calculator gives me back a fraction answer, and that's 3 over 22. So plus 3 over 22, y to the minus 3, x to the minus a half. Okay. Now again, that is a perfect answer. If you're not, what I wouldn't mind doing is maybe throwing, maybe putting them terms back to the bottom of a fraction. But if you're not 100% confident in that, you'd nearly say leave well enough alone. But if you're a little bit comfortable in it, go ahead and put variables with the negative powers back under the fraction. So in this case, I would have minus 14x over y to the plus a half. But that could change back to the square root of y. Okay? because I would originally, I'm leaving out sort of a middleman here. I would have x over y up to the plus a half because I'm taking the y down. But don't be afraid, go a little step further and change that y up to the half to the square root of y. The same idea here again. Never mind about that fraction, just keep him outside, okay? Don't let him just stay outside, never mind about him. Now I'm going to take both of these letters down, and y to the minus 3 in the top would change to y to the plus 3 in the bottom. The same idea with the x, it would change to x up to the plus a half on the bottom here. But I'm actually going to go one little bit of a step further and change it to the square root of x. Okay, and that's the final answer. But as I said, if you got to that stage, I think we're happy enough that that's correct. If you're not comfortable with changing back into fraction format. Now let's find the next partial derivative. So I'm just going to take my z down again because I haven't that much space on the whiteboard. There's my z. Okay, so let's write down what are we looking for. We're looking for del z, del y. Just put it in a box to sort of to lay out your answer in sections. Okay, the same idea. Make two empty boxes or two bins and throw whatever you want to ignore into the bin. So I'm differentiating with respect to y this time, so I do not care if there's about any numbers or any x terms. So in the first term there, I don't care about this minus 7 or the x squared. All I care about is that y to the minus a half. Same over here. I don't care about any of them numbers, that fraction or the x terms. All I care about is y to the minus 3. And throw the fraction and that x term in there. Now there's no harm again in just writing a sort of a dummy equation underneath. Just anything that replace them boxes by any silly number, just to check how would you differentiate an equation with them numbers if they were just boxes, plus anything at all, 5y to the minus 3. So what would we do in that case? The minus a half would come down, but there's a 3 there to meet it, so go over to the calculator and multiply 3 by minus a half, then take 1 off that power. Again, minus 3 will come down, but there's a 5 there to meet it, minus 15, and take 1 off that power. Okay, so we treat the boxes the same way, just treat them as numbers. So we have del z, del y equals, so again the minus a half comes down, so I'm going to have minus a half in front of the box, and take 1 off that power. So check it out in the calculator. It's minus a half and I'm taking 1 off it. Minus 1 over 2 minus 1. And I get minus 3 over 2. Okay, minus 3 over 2. Now start again with this term, take the minus 3 down in front of the box and take 1 off that power. Now be careful about that when it's a negative power. Do not say minus 2 here. Everybody makes that mistake. You think of it, you're going down the number line. If that's the number line there's minus 2, minus 3, minus 4. When you take 1 off, when you subtract 1 from a number, you're looking that way, you're going down that way. So minus 3 goes over to minus 4. So when I take 1 off minus 3, I don't get minus 2, I get minus 4. Right, and throw everything you ignored back into the box. Minus 7x squared, 3 over 11, x up to the half. Now just do a little quick cleanup. So numbers with numbers and letters with letters. So I'm going to get minus a half by minus 7. If you're stuck on that, just check it out in the calculator. Minus a half times minus 7. And I get 7 over 2. X, don't touch the x, is fine. And the y, the minus 3 over 2. Okay. The next time I'm going to get minus 3 by 3 over 11. Try it in the calculator. Minus 3 times 3 over 11, and I get minus 9 over 11. So I have minus 9 over 11 x to the half. He's fine there. Y to the minus 4. Okay. Now I know I said earlier that that would nearly do that expression there. And if the question just said find the partial derivatives, then yes, that's a perfect answer. But the problem is when you're asked a multiple choice question, you see that is the answer. But what the choices might, none of the choices may be written like that. The choices we're looking for you, we're kind of waiting for you to go a step further and take any variables up to a negative power back down to the bottom of the fraction. So I'm afraid it's not true when I say I'll leave it. It's fine. Try and get a bit more confident and take in the terms up to a negative power back down to the bottom of the fraction, because that's what a multiple choice answer might look like. None of them may look like that, so you'll have to rearrange them to take them back down. Okay, but it's not too big of a deal. So okay, the numbers are fine. Don't touch the numbers when they're on their own. X squared on the top, that's perfect, no problem with that. So when I take that y up to the minus 3 over 2 down, I just change the power of that sign again. I just a y up to the plus 3 over 2. Again, never mind about that fraction, just leave them at the side, don't worry about them. So I'm going to have x up to the half on the top. But don't be afraid to go that bit of a step further and change that to the square root of x. Y up to the minus 4 on the top is going to become y up to the plus 4. Change the sign on the bottom. And that's it.